Good afternoon to all of you. In the today's class, we are going to study about the building material. So basically, in this building material, we are going to study about the brick, which is the important material as far as construction in the civil engineering. And then in the brick topic, we are going to study about the manufacturing characteristics, classification, and uses of the brick, improved brick from the inferior soil, hand molding brick, and clay flash brick. First of all, it is a general picture of a brick which is in red in color, having a size of 20 centimeter by 10 centimeter by 10 centimeter. Okay, so let's come to the brick. It is the most commonly used material in the construction field. Bricks are prepared by molding clay in a rectangular blocks of uniform size and then drying and then burning these blocks. In order to get a good quality of brick, the brick earth should contain the following materials. Likewise, silica, alumina, lime, iron oxide, and manganese. If we talk about the composition of these materials, the first one is the silica, which is the most important material, imparts 50 to 60% in the brick. Silica exists in the clay either as a free or the combined form. As a free sand, it is mechanically mixed with the clay and it combines to form its existing chemical composition with the alumina. With the presence of silica, which in the brick prevents the cracking while shrinking and wrapping of raw bricks. That means while the brick get dry, it prevents the causing of minor cracks in the brick due to the less moisture. It thus imparts uniform shape of the brick. That means it provides the uniform shape to the brick on drying process and after the burning. The durability of the bricks depend upon the proper proportion of the silica and the brick earth. That means the silica content, if lies between 50 to 60%, then the durability of the brick is more. Excess of silica destroyed the cohesion between the particles and the bricks become brittle. That means if the silica content excess, then it is become the cohesionless. While on drying, the particle deteriorates and it shows brittle in nature. Then the second most important constituent is the alumina, which is the chief constituent for every kind of clay. A good brick should contain the 20 to 30% of alumina, and this constituents impart plasticity to the brick so that it can be molded. That means the plasticity occurs in the brick due to the presence of alumina on the drying process. If the alumina present in excess, the raw bricks shrink and wrap during the drying and the burning process. That means if the alumina excess, then it occurs while drying the brick, it causes twisting in the bricks and the brick doesn't remain in its uniform shape. Then let's come to the lime. The percentage of the lime which is live between the 5 to 10%. It prevents the shrinkage of the brick on the drying. It causes silica in clay to melt on burning and thus helps to bind. That means the binding work is done by the lime in the brick. In ancient time, lime is the only material which is used to bind the materials. So in the brick, lime also works as a binding material. If the excess of silica causes the brick to melt and the brick loses its shape. That means if the lime content excess, then the brick loses its shape. Then the few percentage, that is the iron oxide present in the brick, which is near about 5 to 7%, which imparts the red color to the brick, improve the impermeability and the durability. It gives the strength and hardness to the brick. If the present in excess, then the color becomes the dark blue or the blackish. That if somehow after the drying process of the brick, the sum of the bricks are in dark red color or the blackish color, which is due to the excess present of iron oxide, or the bricks are overburned. If the quantity of the iron oxide is comparatively less, the brick becomes the yellowish in color. That means the proper percentage of iron oxide is most important in the brick. Then let's come to the manganese, which is present in the less than 1%, and it imparts the yellow tint to the brick. It is responsible for reducing the shrinkage. That means it is responsible while bricks are drying after the molding process, and it prevents brick from shrinkage, and the excess of manganese leads to the decay of the brick. So let's come to the manufacturing process of the brick. That means it consists of mainly four processes. That is the preparation of clay, molding, drying, and the burning process. First one is the preparation of clay. And if we talk about the preparation, that is unsoiling, digging, cleaning, weathering, blending, and tempering. So unsoiling is the process in which the top layer of the soil, about the 200 mm depth, is taken out and thrown away because it contains impurities and the other materials. So if somehow we are using these kind of soil, it doesn't match with the quality of the brick which we are going to manufacture. The clay in the top of the soil is full of the impurities, and hence it is to be rejected for the purpose of preparing of the bricks. Then after the unsoiling, the digging process occurs, in which the clay is dug out from the ground and it is spreaded on the level ground so that the excess moisture can be removed easily in the atmosphere. And the height of the heap of the clay is about 600 mm to 1200 mm. Then after the digging process, the cleaning process occurs, in which it should be cleaned from the stones, the pebbles, the vegetable matters. If some organic matters occurs, plastic, the all materials should be separated out. These particles are in excess, then the clay is to be washed and then screened. Such a process naturally will prove to be the troublesome and inexpensive. That means if somehow the cleaning process is excess, if the soil contain the most of the impurities, then the suggestion is that the new sites should be selected for the digging process. Then let's come to the weathering. The clay is then exposed to the atmosphere for the softening and the mellowing. The period varies from few weeks to the full season. That means in this, the soil or the clay is spreaded on the open atmosphere so that it goes to the season, and the normal process naturally occurring from maintaining the percentage of moisture in the soil is carried out. The blending is the clay is made loose and any ingredient to be added, and it is to be spread out at stops. It is carried out by taking a small amount of clay every time and turning it up or down in a vertical direction. Then the tempering process. In this process, the clay is brought to a proper degree of hardness and it is made fit for the next operation of molding. Then kneaded or the pressure under the feet of men and cattle for the manufacturing good bricks on a large scale. The tempering is done in a pug mill. A typical pug mill is capable of tempering sufficient earth for the daily output of 15,000 to 20,000 brick. Then let's come to the molding process. In this, the preparation, after the preparation of the clay, then it's come to the molding, where the shape of the brick is given and the prepared mixture is filled in a mold, then pressed, and the molded bricks or the shape attained by the brick is taken out and it is kept in open atmosphere so that the sufficient or adequate moisture in the brick can be achieved. It is done by two ways. First one, that is hand molding, and second one is a machine molding. In hand molding, the bricks are molded by the hands or the manually. It is adopted when the manpower is cheap and it is readily available for the manufacturing process of the brick on a small scale. Where the bricks are manufactured on a small scale, the hand molding bricks are most of the time it is used. And it is to be said that the hand molding bricks are evenly more durable in the ancient time. The molds are the rectangular boxes which are open at the top and the bottom. Then they may be made up of wood or steel, that is the molded shape or the mold. The strip of the brass or the steel are sometimes fixed on the edges of the wooden mold to make them more durable. Because due to the continuous contact with the moisture, the wood get decay and lose its strength or its shape. So the obtained brick doesn't having the proper shape. So it is to be suggested to adopt or to provide the brass or steel corners or the edges in the wooden molds. It is prepared from the combination of steel plate and the channel. The thickness of the steel is about 6 mm. They are used in the manufacturing of the brick on a large scale, and the steel molds are the more durable than wooden and turn out bricks of uniform size because the steel doesn't decay and it doesn't deform its uniform size. Then the table molded bricks, this process in which the bricks is just similar as above, but in this case the mold stands near the table of size 2 meter by 1 meter. That means the molding is done on a plain stable table so that the even pressure is applied on the mold and the brick getting on the table and send it to the further process of drying. Then, however, the efficiency of the molder gradually decreases because the standing at some places for or longer duration is can be hectic or problematic. So that the efficiency is decreases and the cost of the brick is also increases when the table molding is adopted. Then let's come to the machine molding. It is can be divided into process. First one is the plastic clay and second one is the dry clay. In the plastic molding, the such machine consists of a rectangular opening having a length and width equal to the ordinary brick. And the pucked clay is placed in the machine and it comes out through the rectangular opening. These are cut into the strips by the wires at the frame, and the arrangement is made in such a way that the strip thickness is equal to the brick are obtained, and it is so called as a wire cut brick. Then the dry clay machine. In this machine, the strong clay is finally converted into the powder form, and a small quantity of water is added, and then to form a stiff plastic paste. That means the preparation and all the works done, and finally the output is getting, and such a paste is placed in a mold and then pressed by a machine to form dry and well-shaped brick. This does not require any drying process. Then the drying is the dampness of the brick. If burnt are likely to be cracked and distorted. That means the after the molding process, the brick is kept for drying so that the adequate moisture in the brick can be obtained. And hence the molding bricks are dried before they are taken for the next operation for burning. For the drying of the brick are laid longitudinally in the stakes of the width equal to the bricks, and a stake consists of 8 of or 10 tiers. The bricks are laid along across the stock in an alternate layer, and all the bricks are placed on the edges. The bricks are allowed until the bricks are become leather harder or moisture containing up to the 2%. So that until the 2% of moisture is obtained, then the brick is allowed to kept in an open atmosphere or in an artificial atmosphere, just like oven, so that the adequate moisture can be obtained easily. Then last one process, the burning process, in which the burnt bricks are the burned at a high temperature to gain the strength and durability, density, and the red color appearance. All the water is removed at the temperature of 650 degrees Celsius, but they are burnt at a temperature of 1100 degrees Celsius. The fusing of sand and lime take place at this temperature, and the chemical bonding takes place between the material after the temperature is cooled, and resulting in the hard and the dense masses. The bricks can be burnt by using the two methods, that's the clamp burning and the clean burning. So we will discuss the later on the clean and the clamp burning. And so in this lecture we have studied about the preparation of the brick molding drying process, how the brick is prepared, and how the output is getting. In the next class, we are going to discuss about the classification on the bricks, that is the class A, class B, class C, and class D. And later on, we will discuss about the properties of engineering bricks.